Okay, in this video we are evaluating one-sided limits algebraically and limits at infinity algebraically. Alright, the first thing we do is what we always do with a limit, and that is simply to put in that value of x for x. If I just put 3 in for x, I get 1000 minus 10. That is not 0, so I know there's nothing funky going on with this problem. 3 in for x is not 1000. This is like too many videos in one day. But anyway, 3 in for x, that'll be 27 minus 10. That is 17. And 3 in for this x, that'll be 9 plus 9. That is 18. This is just 18 over 7. Nothing funny going on. That's just it. If I put 4 in for this x, also nothing funny going on in this time. 2 times 16. 2 times 16 is 32. 32 minus 10 is 22. 4 in for x, I get a 3. 3 over 22, that's just it. Nothing funny, just plug in. Pi over 6, in for x. I don't care if it's one-sided. I'm still just plugging it in first. Okay? Pi over 6 in for x. Sine of pi over 6 is a half. A half minus 1 is negative 1/2. Cosine of pi over 6 is square root 3 over 2. Multiply top and bottom by 2, and we're going to get a square root of 3 over negative 1. That is negative square root of 3. Okay, so always first just plug in, see what you get. Okay, now this time when I plug 2 in, I get 0 on the bottom. Now things have changed. I got 0 on the bottom, so it's not going to be as easy. On top, however, it is easy. I just get a 3. So there's a 3 on top. On the bottom I got a 0, which means that this is going to be DNE. That is going to be DNE. But in a multiple choice, that might not be one of the answer choices. It might be a positive or a negative infinity for your answer choices, and you need to distinguish which is it. For the one-sided limit, that means I'm approaching 2 from the right, a little bit higher than 2. So I'm going to plug in a number that's a little bit higher than 2, like a 2.1. That's going to make this bottom, yes, it's going to 0, but it is positive. Okay, it's approaching 0, but positive. So which infinity is it? A positive divided by a positive is a positive infinity. So if it's not multiple choice, you are welcome to just stop with DNE. If it is multiple choice, you may need to figure out which it is, positive or negative infinity. So I'm going to go with the approach that these are multiple choice, all right, because they will be on the test, and they will be for AP as well, for the AP exam. All right. We're approaching 3 from the left. If I plug in 3, I do get 0 on the bottom. Up on top, though, what do I get up on top? I get negative 2 times 5, right? Okay, so again, I'm approaching 3, but from the left, a little bit lower than 3, so maybe I'll plug in a 2.9. Only to see what the sign is. I know this is going to 0. Which sign is it? Well, if I plug in something a little bit less than 3, I'm going to get a negative here. So yes, it's going to 0, but it's negative. So is this positive or negative infinity? Negative over negative is a positive. Positive infinity. DNE. Okay? Multiple choice. Okay, free response. Okay, let's plug in 2. If I plug in 2 for x, well, if I plug in 2 for x, I immediately see I'm going to have a 0 on the bottom here. I'm going to have a 0 there, but here I don't have 0. Here I just have a 3. Here I don't have 0. Here I just have a 9. But here I have another 0. Okay, since I have a 0 over a 0, that means we have a whole, right? We have a hole, which means the limit exists. I can reduce these because it's only a limit. We're not equal to, it's only a limit. So I put 2 into the remaining x's and I get 9 over 3, which is 3. Okay? Oh, you know what? I did something here. I reduced those, but I didn't reduce correctly, did I? I reduced those, but they don't reduce to a 1, they reduce to a negative 1. So this will be a negative 3, not a 3. Okie doke. Number 7. We're approaching 5 from the left. 5 from the left. So first plug in 5. I get a 3 on the bottom. Up on top I get a 0. It doesn't matter if it's positive or negative. It's a 0 on top. So this whole thing is just 0. 0 on top, just 0. 0 on the bottom, you got a problem. Okay, over here. Negative 1 goes in for x. I have a 0. Okay. Up on top, though, negative 1 in for x, I have a 1. Negative 1 in for x, I have a negative 4. So I need to find out which one on the bottom. This is 0, but is it positive or negative? Positive or negative? I'm approaching negative 1 from the right. So I'm going to put something a little to the right of negative 1, maybe a negative 0.9. If I put in a negative 0.9, this is going to be a positive. Yes, it's 0, but it's approaching 0, but positive. So I know this is going to be an infinity or negative infinity. Which one is it? Negative over a positive is a negative. So this is negative infinity. Okay. If I put in a negative 2, I have 2 times negative 2 squared. So 2 times 4 is 8, minus 8 is 0. So I have a 0 on the bottom. Up on top, what do I have? I have negative 2 in here. So that's 4 plus 2 minus 6. I have a 0 there as well. So this is a hole. So I treat it like we did with any other hole. I'm going to factor and reduce and eliminate the hole. The top factors into x minus 3, x plus 2. For the bottom, I'm going to first take out a 2. So I have a 2 outside, and then I have an x plus 4, x plus 2, x minus 2. Difference of squares there. The x plus 2's reduce out because x is not equal to negative 2, that we can reduce those out. They reduce to a 1. I put negative 2 into my remaining x's just like I did in our last unit. Our last section, I mean. Negative 5 up on top, 2 times a negative 4 on the bottom. That's a negative 5 over a negative 8, or 5 over 8. Okay, last little line here. X is going to infinity. As x goes to infinity, only the highest powered term on top and the highest powered term on the bottom are relevant. Everything else, it's like it's not there. For a limit, it's not there. So this is the same thing as the limit as x goes to infinity of. I'm going to keep everything except I'm going to reduce my x's. Now let x go to infinity. We have infinity on the bottom, but we have a negative over a positive. Infinity on the bottom is going to make this whole thing go to 0. Infinity on the bottom, it goes to 0. Infinity on top goes to infinity. Okay, x is going to infinity, so we only consider the highest powered term on top and the highest powered term on the bottom, and we reduce our x's. Reduce your x's. This time the x's reduce out completely, and we have no more x's left. And when you have no more x's left, just get that number. Okay, another x going to infinity. Only examine your highest powered term on top and the highest powered term on the bottom. Reduce your x's. Going to have a 3x squared on top and a 7 on the bottom. Now let x go to infinity. We're going to have a positive infinity, all these positives. That's that.